going to do for these is just talk about stating the null and alternative hypothesis. This is the idea of step one of what we want to go through when conducting a hypothesis test. So it's all in the wording of the problem that tells us how to set up our null and alternative hypothesis. So let's look at part A. An old antacid provided relief for 70% of the people who used it. A pharmaceutical company has a new drug they want to test to see if it is more effective. So again, for the structure for our hypotheses, we're going to have some null hypothesis, which is an assumption that the proportion is some value. And then alternatively, what we want to prove, which again, we'll be comparing it to that same number, but then it's just a matter of do we put the more than, or the less than, or the does not equal sign. So from this, they're talking about an old antacid, and it has this proportion of success, 70%. And a pharmaceutical company has a new drug that they want to test, and they want to test to see if it is more effective. So often it'll outline what they want to test, and often what they want to test is describing our alternative hypothesis, because our alternative is always what we want to prove. So, for us, setting up our null hypothesis and our alternative hypothesis. What we want to assume is that if they're making a new drug, it should be just as effective as the old drug. So we're going to assume this proportion that feel relief from the drug. We're going to assume this is the same 70%. Then what we want to prove is we want to prove it is more effective. So in terms of percentage that are getting relief from the drug, we want this to increase. So we want to see is this proportion, we want to see it be larger than 0.7. Now setting up this null and alternative hypothesis, it sets up a lot of the entire hypothesis test. Everything that we conduct from here really relies on this setup right here. Not even just numerically, but especially the symbol, since we're using this more than symbol, it tells us what type of test we're going to run. And we're going to end up with 3 different types of tests that we can run, and this one is called a right tail test. A right tail test is always going to come through when, if we look at our alternative hypothesis, when we're trying to prove that the proportion is more than some number. That's always going to lead to this right tail test. What this is going to do is called a right tail test because it tells us where to find our p-value. So if we build this distribution all under that null assumption being true, so you get our distribution, and we're always going to end up at the standard normal distribution, so we have 0 in the middle there. What we're going to have is when we find our sample data, we're going to have some z-score, and it should be landing to the right. The idea being that if we're trying to prove it's more effective, we should already have sample data that supports that idea, so we should be landing somewhere over here with our test statistic. And with these right tail tests, the p-value that we want to find is always at that z-score and larger. And this is going to be our p-value. So this is how, as soon as we determine the null and alternative hypotheses, and especially the alternative, once we determine what symbol we're using there, it tells us where the p-value is going to occur. If we're only looking more than, it's going to land in this more than region, or this right tail. So this gives us a visual of the setup of the hypothesis test just based on what we see here with the null and alternative. In part B, we have a company is concerned that too few of its cars meet pollution emission standards. They have 1,500 cars, they sample 56 and find that 43 meet emission standards. They want to test if less than 80% of their fleet meets emission standards. Again, where it's describing the test, that's really linking to alternative hypothesis. And with our hypotheses, we're stating this 80%, this is going to come through in our null and alternative hypothesis. even though they gave us these other numbers, what we want to take note of is all of this is sample data here. They took the sample of 56 and found that 43 meet emission standards. With the sample data, that comes in later in the hypothesis test. Your sample data will never show up in the null and alternative. This is where we're getting our evidence from. So for the null and alternative, with this one it might actually make more sense to set up the alternative hypothesis first, in that they tell us that we want to test if the proportion is less than 80%. So just interpreting that, our proportion less than 80%. So just interpreting the meaning there to set up our alternative. And what that means is then in the null hypothesis, it has to be, it's always P, and we always have our equal sign in the null hypothesis, and then numerically those are always the same numbers. So this would be our null and alternative, assuming it is 80%, and we want to prove that it's significantly less than 80%. This is going to be our left tail test. This is where in the alternative hypothesis we'll see the less than symbol, less than some number, and what's going to happen when we conduct this test is once we find that test statistic and we're taking it to our standard normal curve, well, our z-score should be landing somewhere over here to the left-hand side. Again, it should be supporting, if we want to prove the proportion's less than 0.8, it should already be landing in this kind of less than region. So we have our z-score somewhere over there, and when we find the p-value, it should be the probability of seeing results as extreme or more extreme. And so this would be as extreme, and then to have more extreme, we'd shade into the left to get at this idea of less than that value. So this right here, that would be where we find our p-value. So our alternative hypothesis gives us an idea of which direction to look in, which direction to shade in to find our p-value. Our third scenario is we're going to look at the official poverty rate was 14.8% in the US, and a city official wants to test if their county has a different poverty rate than the rest of the US. So we have this population proportion of 14.8% for the whole United States, and what they want to do is test if their county has a different poverty rate. So notice they're not trying to prove that it's a higher poverty rate or a lower poverty rate. They just want to describe it as different. And this is where, in the alternative hypothesis, we're going to see the does not equal sign. So we're going to assume the proportion's the same as the rest of the United States with a 0.148. And what we want to prove is that it's significantly different from 0.148. It's either higher or lower, doesn't matter. We just want to show that it's different. This brings through our two-tail test. And this happens whenever we have an alternative hypothesis that uses the does not equal sign. And there's kind of two ways that this can occur. Let's talk about two examples of this. So when we go through our hypothesis test, we get a single test statistic out. What creates the two different scenarios is either our test statistic's going to be large and landing on the right-hand side, or our test statistic's going to be small, landing on the left-hand side. Either way. So let's talk about this scenario where our test statistic was larger than 0. So again, our p-value is the idea of the probability of seeing results as extreme or more extreme. So as extreme and more extreme would bring through this right tail. But something we want to bring through with these is that where we land here with these sample results, in terms of just being different, how we're landing here is just as different from 0 as landing over here. We end up with this mirror image, and my drawing's not perfectly symmetric, but it should be, of how this differs is exactly the same as how that differs. in terms of this probability of seeing results as extreme or more extreme, we get this tail, but we also get this tail on the left-hand side. So both of these areas together, combined, that creates the p-value. We'd want this probability of seeing those results and more extreme, which is also happening over here in terms of just being different. If our test statistic lands less than 0, same idea. We'd be taking the probability of as extreme and more extreme, and just how this result differs from 0, we have the symmetry of a similar result being just as different and those values that are more extreme. So this is why it's called the two-tailed test, because where you kind of end up with either a right tail or a left tail, you always want to double that tail area to get the p-value out. So in calculating the p-value here, you're going to have this one extra step of multiplying by 2 by finding that tail area. So this is how we set up our null and alternative, and with that comes through these different types of tests that we can run.